So today we're going to talk about solving quadratic equations by using the quadratic formula, and also how to determine the number of solutions of a quadratic equation by using part of the formula called the discriminant. If you remember, a quadratic makes the parabola, and it either crosses the x-axis in two places, touches it, so it basically intersects it once, or not at all, which is 0, and that's the number of solutions we're talking about. So what we've done so far is solve quadratics by graphing, factoring, solving using the square roots, or completing the square. But sometimes you can't solve using any of those methods. You can always solve using the quadratic formula. And either it has a solution or it doesn't, but using the quadratic formula will show you what you need to do empirically. The quadratic formula itself is negative b plus or minus the square root of b squared minus 4ac all over 2a. And the a, b, and c refer to the parts of the quadratic formula in standard form. A being the coefficient of x squared, b the coefficient of x, and c is the constant, which you know is the y-intercept. So we want to look at those three parts in order to use the quadratic formula. There's a pretty cute video to help you remember, and a song to help you remember the quadratic formula. So let's take a quick look at that. Here we go.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
So that's the quadratic formula, and you'll notice that it's the negative b plus or minus the square root of b squared minus 4ac all over 2a, and it makes it easy for you to remember the formula. So let's try and use this formula. Here is our equation in standard form, 6x squared plus 5x minus 4 equals 0. So the first thing we wanted to do is identify the a, b, and c. A will be 6, b is 5, and c is actually negative 4. Don't forget to change all of your subtraction to adding the opposite so you don't misuse that sign. And with the quadratic formula, it's particularly important since you're going to be doing quite a bit of multiplication, and you don't want to end up with a negative when it should be a positive. Once we've identified a, b, and c, we want to use the quadratic formula. I always expect that you'll write down the formula itself. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And it's x equals because, again, you're looking for the x-intercepts, or where the parabola crosses the x-axis, where y equals 0, and it's the x value that you're looking for. So we're going to substitute our values in for a, b, and c. And if you notice again here, we've got that negative 4 being multiplied, and I recommend making this a plus negative 4 in this case as well. So when you simplify, you've got negative 5 plus or minus the square root of 25 minus negative 96, or plus 96, all over 12. So we're going to keep going, and we get negative 5 plus or minus the square root of 121 over 12. And 121 is a perfect square, so we have negative 5 plus or minus 11 over 12. Now here's where you want to make sure that you're clear that the square root has both a positive and a negative root, because we have to make two equations. We want one that says negative 5 plus 11 over 12, and one negative 5 minus 11 over 12. We're going to get two different solutions, or two places where our parabola crosses the x-axis, and that's going to happen where x is 1/2 and x is negative 4/3. And those are our two solutions. Let's try it another time. X squared equals x plus 20. Well, in this case, it's not written in standard form, so that's the first thing that you need to do. You want to get your equation in standard form and identify a, b, and c. So we have x squared plus negative 1x plus negative 20 equals 0. Again, using the quadratic formula, substituting for a, b, and c, and simplifying. Don't forget you can pause this video at any time to copy down this information so you have it in your notes. Again, we're going to want to keep simplifying this. So we've got the perfect square of 81. So it gives us 1 plus or minus 9 over 2. We want to write two equations. And x is 5 or x is negative 4. Again, take a moment to write down the information. I'm going to have you do this next one and then we'll check the work. So this is the information. You're going to want to write it in standard form. Pause a moment and then let's check your work. Okay, welcome back. Hopefully the first thing you did was write in standard form and identify A, B, and C. Great. Next, you want to write down the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Substitute the values for a, b, and c, and begin to simplify. So now we have, again, 121 is in our radical and it's a perfect square. So we have negative 9 plus or minus 11 over negative 10, which we simplify with two equations. And we have a result of x being negative 1/5 or x equals 2. Now in all these cases we've had two solutions for our quadratics, but as you know the parabola doesn't necessarily need to cross the x-axis in two places. Sometimes the parabola won't touch at all and sometimes it just touches it once, and that's when we use something called the discriminant. The discriminant is that part inside the radical, b squared minus 4ac. And it's important to remember that if a number inside the radical is negative, that it's an imaginary number. If the number inside is positive, you can find a solution. And if the number inside actually equals 0, there's only one square root of 0, and that's 0. And that's how we use the discriminant to determine the number of solutions. If you notice here, when you have a positive discriminant, meaning the information inside gives you a positive value, you have two solutions. If the result of simplifying everything in the discriminant is 0, you only would have one solution because the square root of 0 is 0. But if you have simplified inside the discriminant and you find out you have a negative solution, well, there are no intercepts because there is no square root of a negative number. Again, if it's greater than 0, there are two solutions. Equaling 0 is one solution, and less than 0 is no solutions. Take a moment to write this down. Okay, we're going to try using the discriminant. Again, it's just the part of the quadratic formula inside the radical, so it's the b squared minus 4ac. So we have to identify the b and the a and the c. So we've got a is 3, b is negative 2, c is 2. Then we use the discriminant itself, b squared minus 4ac. We continue to simplify. And in this case, I notice that I'm going to have a negative 20. That means there's no solution. There isn't a solution because you can't have a square root of a negative. In the next one, I've got a is 2, b is 11, and c is 12. b squared minus 4ac is my discriminant. I simplify, and after I simplify, I get a positive solution, and because it's positive, there are two real solutions to my quadratic. You try the third one and see what you get, and when you come back, we'll check. Okay, welcome back. Let's see how you did. A is 1, B is 8, C is 16. You use the discriminant, b squared minus 4ac, substitute the values, and 64 minus 64 gives us a value of 0. Because the square root of 0 is 0, there's only one real solution. So we can use not only the discriminant but the quadratic formula to give us information. It is really important to use the discriminant before you continue to solve anything else, because if there's no solution, you don't have to do the rest of the problem. Let's try and do an application of this. The height in feet of an object shot straight up with an initial velocity v in feet per second is given by h equals negative 16t squared plus vt plus c, where c is the beginning height of the object above the ground. Well, if something comes off the ground, the initial height is 0. And we've been using this vertical velocity model for other problems in factoring and in our quadratics. So in this case, we've got a ringer and a carnival, and it's 2 feet off the ground, and it goes up with an initial velocity of 30 feet per second, will it reach a height of 20 feet? Well, we have to figure out what the parts are. Well, we know that the height we're trying to get to is 20. So we're going to substitute 20 for h, and 30 for v, and 2 for c, because it started 2 feet off the ground. So velocity at which it's traveling was that 30 feet per second. Once we have this information, we can subtract 20 from both sides. So now we have it as a quadratic, and we can use what we know about the discriminant to decide if it's going to reach the height or not before we figure out where that's going to be. So the discriminant says b squared minus 4ac, that when I substitute, I get a negative value, which means there really is no real solution. So the ringer is not ever going to reach a height of 20 feet if the velocity is 30 feet per second. But what if the weight is shot up with a velocity of 20 feet per second and starts at 1 foot off the ground? Well, if it didn't go up from before, I doubt it's going to be going up now, but let's just check. And looks like b squared minus 4ac, that's negative as well. So it's really not going to do much better. Okay, now that you know how to use the quadratic formula and understand the discriminant, I want you to try a couple of problems in your notes, and then we're going to check to see if you were right. So go ahead and write down these 2 questions in your notebook and try and solve them. When you're done, come back and check your answer. Okay, welcome back. For number 1, you get about 0.23 or 1.43, and that would be if you used your calculator and determined the value in the radical. And for number 2, how many solutions are there? Well, the value is positive, so there are 2 solutions. Let's try 2 more. Try these 2 problems and come back and let's check your answer. Okay, welcome back. If the discriminant is used, the discriminant is actually 0 here, so the object is going to reach its maximum height of 40 feet once. Well, that makes sense, because if it goes up in the air, it's not going to bounce necessarily. And for number 4, if this is our quadratic equation, how many solutions? From the discriminant, we saw that there were 2, and those 2 solutions are 2 and negative 3/8. Congratulations, now you know all about the quadratic equation and how to use the discriminant.